Okay, listen up.
For each given angle measure.
I gotta go over something really simple. You might be rusty on this, maybe you've forgotten it. It's something called an inverse trig function. I'm gonna go back to basics. Here, the first triangle I drew for you was a 5, 12, 13. Let's suppose this was some angle theta. One way to talk about this would be, I could say, for example, the sine of my angle is 5 over 13. Is everyone fine with that? Okay. Now, we just learned about inverse functions, right? Inverse, so there's a function, there's an input and an output. So the inverse function should invert that, should reverse it. So there is an inverse function that looks like this. Okay, how do you feel about that?
Yeah.
So what does the sine function do? You tell it the input is an angle and the output is a ratio. The inverse sine function, the input is the ratio and the output is what angle on a right triangle would produce that opposite over hypotenuse ratio. Make sense? You okay, Zarita?
Yes, my mind is blown.
Mine exploded. Okay. Now, here's one of the usefulnesses of trig is just like, well, suppose for whatever reason you knew that, building something, whatever, I need a triangle to have a 5 to 13 ratio between the height and the hypotenuse. What angle does this need to be to achieve that? Well, in the olden days, they'd have a table. They'd have like a book that you would just look this up in a table. What angle has well, you convert it to a decimal first, and then you look it up in the table. What's this ratio? Or what angle produces this ratio? Nowadays, with the Mr. Quackmulator, you'd go inverse sine of 5/13. So if you were curious, I know you were all clamoring to know, it turns out this angle is roughly 22.6 degrees. That decimal goes on forever. But Feely report? Feel good? So what does that have to do with Eddie? You've ruined my life. I'm lost now. Can you just read me was it number 13 or 14?
13.
13 says, just kidding, Eddie. Sine, don't say sin. And if anyone, I'm really setting myself up for a disappointment here. If you say sine to the negative first power, you will upset me greatly. We read this as inverse sine.
Because it's sin to the negative first power.
Oh, yeah.
Got it.
It's sine, cosine, tangent, cosecant, secant, and cotangent. Not sin, cos, tan, cot, cusk, and sec. Okay? Those are not how you say that.
That sounds right.
Please have mercy on me. Please have mercy.
Cosine to the negative first
So
power.
it's sine of, it's the inverse cosine, right?
Yeah.
So watch this. This is actually very easy. Okay, it looks confusing, but it's easy. So the first thing you do is you look to the inside, like we usually do with these kind of things when parentheses are involved. You look at this and you say, what is that talking about? What is that referring to? That is referring to an angle out there somewhere. Because watch this. What if I said, well, the cosine of some angle equals 1/3. We know that's got to be true. There is some angle out there whose cosine is 1/3. That's the same as saying that the inverse cosine of 1/3 would be that angle. So what does that tell me? This tells me that this thing I've circled is referring to some angle out there that achieves this ratio. Do we feel okay about that? That make sense?
My feelings are not hurt.
Okay. So this by itself just refers to this angle. And yeah, you could use a calculator to tell us how many degrees is that angle. That's not what we're doing here, but you could. So then the broader question is, what's the sine of that angle? Okay, so do you see how this is actually pretty much the same problem we were doing before? So let me write this out to clarify. This is the exact same thing pretty much as saying, if the cosine of an angle is 1/3, find the sine of that angle. Does that make sense?
Yeah, like the f of x, g of x thing, kind of.
Yeah, kind of. Yep. So Pythagorean theorem, I'm going to call this a temporarily. Go 1 squared plus a squared equals 3 squared. A squared is 8. So a is the square root of 8, which you can simplify that to 2 root 2. Is everyone okay with this?
Yes.
Maybe it's been a while since you did that. Have we done that in this class?
Yeah.
Much? A couple times. We done it a little bit, but not a ton. Oh yeah, especially with like quadratic formula type stuff. So anyway, so this guy here is 2 root 2. And so the answer to this question is the sine of this angle was 2 root 2 over 3, opposite over hypotenuse. Do we feel like that makes sense?
Yeah.
Nope. Any questions? Okay, try to do the next one on there while I'm erasing this, and then we'll all double check our answer, and then we're gonna move on to the dreaded radians, the scariest thing in the world.
Physics made me hate radians.
You loved them before.
No.
You hate. Well, you just said.
No. I said physics. When we talk about radians and physics, it made me hate them.
So you liked them before.
She had no opinion on them before.
Neutral.
No, I didn't.
But now you love them.
Two squared.
The full story arc was at first I hated them, but now they're my favorite.
I don't believe it.
Right, Taylor? Taylor. Just admit it. Just admit that you love
I
them.
don't hate them. It's just like.
No, you love them.
So this one's a two.
All right. Keep doing that problem. Do that next one. I want to make sure we all understand.
Numbers.
Don't
Sean
they look glorious with the
style.
middle part?
Savage.
His style.
Okay.
The middle part. Give me the middle part. Give me the middle part.
Then the cosecant.
Give me middle
Or
part.
the inverse of the sine. Sine is. Sine.
Yeah, that is a good circle. Good job, that guy. That's a nice circle.
Like,
Thank you, Sean.
It's all middle part. Sean.
This is.
Uh,
Doing it, you have to mark which angle you're talking about.
Did you guys
First started.
get the problem done? Did you figure it out?
We did this yesterday.
No, did you do it?
Yeah.
You
did not. You did not do it. Sean, I just explained it.
But I did it.
It says
No, you did
rewrite
not.
the
I did.
expression.
Look at it closer. There's 2 lines. Because I did it.
I'm talking about number 13, bro.
Yeah.
There's no answer. Did you not listen to anything?
Just I just rewrote it.
It says rewrite the expression.
You gotta find.
Oh my God. We have to find the answer.
What?
Let's just say
Yeah, the
rewrite it.
instruction just says rewrite each expression without using trig functions.
Without using trig functions. You use trig functions.
I don't know what a trig function is.
Yeah.
Sine, cosine, tangent.
Oh.
Oh my goodness. That couldn't have been clearer, Sean. I showed you exactly what I was looking for. You see how the final answer was 2 root 2 over 3? That is an equivalent expression that doesn't use any trig functions. You scoundrels. My goodness.
Sine, so,
Did everyone get 13B?
root 5.
What's the answer?
Root 5.
Root 5 over 2. Okay. Are there any questions on that?
I don't understand any of it.
Okay. So someone tell me what is the so 13B is asking, it goes
Cosecant.
cosecant of
The inverse of tangent.
inverse tangent
Two.
of 2. All right. Quiet down. Going over this one for the people who are confused. You look at this, it says this inside part here. This is referring to some angle whose tangent is 2. So you can rephrase this and say, if the tangent of some angle is 2, then what is the cosecant of that angle? Okay? So let me draw a triangle that reflects this fact. The tangent of my angle, the opposite over adjacent, has to be 2 over 1 to get that ratio. If you do the Pythagorean theorem, 2 squared plus 1 squared equals the hypotenuse squared, you get root 5 for the hypotenuse. So now you can answer this question. What's the cosecant of your angle? If you're still having a little bit of trouble with the whole cosecant thing, just take the definition. It's the reciprocal of sine. So according to my triangle that I drew, the sine of my angle is, what's the sine of my angle? 2 over root 5. So the cosecant of my angle is the reciprocal, root 5 over 2. So that's the answer to my question. That's the final answer. Okay? All right, you guys ready to talk about radians, your favorite thing in the whole wide world?
No.
Yes, you are. Yes, you
I'm gonna never miss school.
are. What's wrong, Cheyenne?
I need to never miss school again.
We didn't do anything yesterday. Did you miss the day
know.
before as well?
Yeah.
I recorded class. You can watch, you can see what you missed.
Yeah, I should.
All right. Everyone listening? Don't miss this. April, don't miss this. I'm gonna explain everything. How many degrees are in a circle?
360.
360. Why?
Because it's a circle.
Because it's a circle?
Because all the
They
angles.
said.
Well, it's a good question. It's like saying, why do we have 10 symbols that we use to describe all of our numbers?
Because that's how it is.
Well,
They
It is what
chose
it
it.
is.
could you have, is it conceivable to you that you could have been raised in a society where there's only 4 symbols to describe numbers?
Yeah.
It goes 0, 1, 2, 3, and then to represent 4, you have to then start reusing the symbols like we do. So that's conceivable, right? So,
There's no reason.
so there might be there probably some historical context to why there's 360 degrees in a circle, but I'm telling you that ultimately it's an arbitrary number. You could invent a new measurement of angles called debris, that there's 100 debris in an angle, or sorry, in a circle. Right? What's to stop you from cutting a circle up into 100 pieces and then calling, each one of those chunks, I'm calling that a debris.
Nothing.
You get what I'm talking about? One of the reasons why 360 emerged as a useful number is it's highly divisible. You can divide it by 2, divide it by 3, 4, 5, 6, 8, 9, I think 9. Yeah.
Yeah.
10, 12, 15, 16, you get the idea. Like you can divide 360 into a lot of different pieces, into a lot of nice, convenient chunks. So it's useful because you can talk about, what's an eighth of a circle? 45 degrees. What's a third of a circle? 120 degrees. You get the idea? Okay, so anyway, I'm trying to introduce you here to this new idea, which is, because usually people get all twisted in their head about radians, but you first need to realize that the 360 degrees thing is arbitrary. So just, you can break away from that and be like, okay, well, what's to stop us from saying that a circle has this many radians? Who knows the answer to this? How many radians are in a circle?
127.2.
No, 2 pi. By the way, how big of a number is that, roughly? 6.28, roughly. So in this case, you're dividing, this is where it gets confusing, because 360 is an integer, so you can kind of like very easily go, just chop that into exactly 360 even pieces. This is a little bit harder to wrap your head around because that's an irrational number. You can't visualize chopping it up into like, because each radian is like a weird, so think about what one radian would be. If there's roughly 6 radians, right, there's 6.28 radians in a circle. 1 radian is what? Roughly how many degrees then?
Roughly 60.
Yeah, 60-ish, exactly. A little bit less than 60. Is this making sense? Like here's a very simple ratio thing for you. If there's 360 degrees for every 2 pi radians, I hope you'll just trust me on that fact. Like that's just a fact. They, capital T, they decided that, right? We'll slowly see why. Why is that so useful? Why does that make our life easier when dealing with circles to have radians over degrees? There's a whole bunch of reasons, but if that ratio holds, then let's see, how many degrees would be 1 radian? You guys see what I'm doing there? This is back to like middle school proportions, right? So if I take a calculator and say, oh, okay, this side's already solved. Right? How do you know that?
I guess.
Oh, you just guessed.
Yeah.
That's 57 point. I thought you were saying the right number. I was like, what?
No.
So I'm just throwing this out here, guys. Don't get confused. So how many degrees are in 1 radian? Well, so 1 radian is roughly 57.296 degrees, approximately. That's not a number you have to memorize or anything. You guys still understand? Are you still with me?
Yeah.
So don't be scared. 1 radian is that. So then you gotta go, well, what the heck? So these radians are some crazy number of degrees. Why would I use them? Well, here's the thing. The radians are most well behaved when there's some fraction of pi. So that's where the whole pi over 6, pi over 3. Let's go over a couple examples. Have I confused you greatly?
Kinda.
Yes.
Getting there.
Not.
Okay, let's just back up. A radian there's roughly 6.28. There's 2 pi radians in a circle. So each of those radians makes up just under 1/6 of a circle. Okay. However, we are very rarely going to be talking about 1 radian, 2 radian, 3 radians. We're going to be talking more about pi radians, or half a pi radians, or 1/3 of a pi radians. Okay, let's watch what it is. So here's radians, and then here, let's say we wanted to talk about the connection between radians and degrees. The first question is just asking us, and maybe it's a lead, and let's do the simplest possible ones. This is again arbitrary. They determined that the positive x-axis is going to be the starting point. There's plenty of good reasons for that we'll learn about later. This position is 0 radians. Okay. Now, Mr. Clock. What's wrong, Shine?
Is this what we learned like at the end of the year last year?
Yes.
Oh my god.
Y'all were learning at the end of the year last year?
Watch. It's not, guys. Open your mind. It's not that complicated. It is not that hard. I promise you. This is a famous thing for a lot of students because I do understand that when you first see it, it seems confusing because you are totally ingrained in the whole 360 degrees thing because we'd be living in a society. But many students, once they finally have accepted this and understand it, they think back, well, what was I so confused about? It's very straightforward, I promise. Okay. So don't turn your brain off.
Okay.
This is 0, and I'm telling you, just trust me that 2 pi is 360 degrees. This is like the definition, okay, of what radians are basically. So, or that's a bad way to say it. This is the start. This is a good starting point. So how many radians is it if I go all the way around the circle? 2 pi. So this position here is not only 0 radians, it's also 2 pi. What if I went around the circle again?
4 pi.
4 pi.
6
pi. You get the idea there, right? So just like on a clock, it would be like, wow, crazy that the arms are in the same position they were yesterday.
Whoa.
Because 24 hours later, they're in the exact same right? Even 12 hours later. Same thing for this. So if you're on a circle and you move 2 pi radians, you're back to where you started. Okay, so this position is starting point and it's also a full circle. So how about this? What if I just went halfway around the circle?
1 pi.
That's 1 pi. Very good. What if I just went halfway between 0 and 1 pi?
Half
That
pi.
would be half a pi. And what if I went halfway between pi and 2 pi?
1.5.
1.5 pi, which is
3/4 pi.
3 halves pi.
3.
1 half, 2 halves, 3 halves, 4 halves.
That's a lot of
Okay.
pie.
Right? This is a good starting point. In fact, most of the time when you're doing calculus and stuff, these are really the 4 points you got to know. Yeah, the other ones certainly come up, but they're not like, these are the big ones, these ones. Because this is where, if you do remember last year, this is where your sine and cosine values hit 0 and 1, or negative. That's why they're so, they come up so often. So, the first question on that little set of questions is, what about pi over 6 then? What does it mean when we say pi, a sixth of pi radians? Let's do the first thing. Maybe I'm just a more visual person, but like, the first thing I would think about is, where does that live on this circle then?
Top right quadrant.
It's up here, right? Because going from here to here is 1 pi. So what does it look like if I go a sixth of pi?
Less than half.
It's like
Less than halfway,
half
good.
of half of half of pi.
Where's a quarter? Where's a quarter pi, by the way?
Right there.
Exactly
in the
halfway
middle.
between 0 and pi over 2 is a quarter pi.
Yeah.
Is a sixth less than a quarter? Yes. Okay. So it's less than a quarter. Okay. And then so all you're gonna do is think about how many degrees that would be. It would be 30 degrees. All right. Have a good lunch. See you tomorrow. We'll pick this up tomorrow.
Well, in terms of pie, how much pie as a regular sized pie tin do you think you could eat? Like how many servings of pie in terms of pie radius could you eat?
Pi over 2. If it's it depends. If it's a lighter pie, like a chocolate mousse pie, and it's really high quality, I could probably eat pie radians.
Okay.
I just remember Mr. Oz